Welcome to Study Loop.
The question asks, says, a grasshopper hops down a level road. On each hop, the grasshopper launches itself at an angle theta naught is equal to 45 degrees and achieves a range r equals 1 meter. What is the average horizontal speed of the grasshopper as it progresses down the road? Assume that the time spent on the ground between hops is negligible. Okay, so I went ahead and wrote down what we were given here. And that is that the initial angle, theta naught, is 45 degrees that the grasshopper is jumping. It jumps a range, r is equal to 1.0 meters. We're on Earth, so we know that gravity, which is going to play a part here, is 9.8 meters per square second. And the question is, what is the velocity of the grasshopper in the horizontal direction, in the x direction? In order to do that, we need to first find the velocity of the grasshopper period when it jumps. So we'll just call that v0. First, we need to find that. What does that equal? In order to do that, we're going to take into account the range formula. Range is equal to v naught, right? Which is what we're going to try to find. It's equal to v naught squared times sine 2 times the angle. I'll redraw that, which is theta naught, okay, divided by gravity, g. And we want to solve for v naught. V naught is squared, so in order to get it by itself, we need a square root. Okay. R gets multiplied by the g. Okay. And this is divided by sine 2 theta. Okay. So if we plug in all the values that we have here, we have this is equal to the square root of r, which is 1 meter, times gravity, 9.8, meters per second squared, divided by sine 2 theta. Okay, so sine 2 theta, theta is 45, is the sine of 90 degrees. So right? Okay, so if you plug all of this into your calculator and figure out what this is, it comes out to equal 3.13 meters per second. Okay, but that is just the velocity. We want the horizontal component of the velocity, or the x component of the velocity. V sub x is equal to the velocity times cosine of the angle relative to x. Cosine because we're dealing with x here. The angle is 45. So times the cosine of 45. Right? V naught is 3.13. So 3.13 times the cosine of 45. You plug that into your calculator and it comes out to be 2.2 meters per second.